Hello, good evening everyone. My name is Kagulo Firdaus and I'm here to take you through a C program of how to solve quadratic equation, finding the roots of a quadratic equation. Well, our first step, we are going to include the standard input-output operations that help us input the variables and include the math operations, because we're doing with math equations. Well, the first part, we're going to write the int main. Well, in C programs, the program is executed after the word main. Whatever you write below the word main is what the program is going to execute, and we want our program to begin from there, and we use the double keyword to list our inputs. Like we have the a, b, c, the discriminant, root 1, root 2, the real part and the imaginary part. Those are our variables that are included in the quadratic equation. Well, we have the do while loop. First of all, we print f and enter the coefficient. Well, the program is going to print the enter coefficient a, so long as a is not equal to 0. A cannot be equal to 0, because if it's equal to 0, then the equation is invalid. A cannot be equal to 0, so we enter the coefficient. Like on our screen, the word enter coefficient is going to come, coefficient a, and we go to the scan part, that scan f, then colon percent 1f, comma, and a. Here we're going to put a, the value of a, in this place value, and you put any number you want of a between 1 to 9 or anything. Put any number, so long as a is not equal to 0. A cannot be 0. Well, that's the do while loop part. Then we go to the second part and print f, enter coefficients of b and c. Then the word's going to come on the screen, that enter coefficients b and c, and we are going to use the scan part, and where the scan part help us put the values of b and c in their respective place values, and b is going to come here and c is going to be here. Well, we get the discriminant. The discriminant in the quadratic equation, well, first of all, is sometimes called the bulldozer. The discriminant part in the quadratic equation is b squared minus 4ac. C, b times b minus 4 times a times c. Well, that's the discriminant. Since we entered our values of a here and b and c, so the discriminant is just going to be automatic, just going to be there. Well, we go to the next part. This is a comment, that condition for the real and different roots. The roots can only be real and different if the discriminant is greater than 0. If after computing this, the value you get is greater than 0, then that means the roots that you're going to get after the whole process, or after the equation, they are going to be real and different. Well, root 1 is equal to negative b plus the square root of the discriminant over 2a, or 2 times a. So that's root 1 is going to be it's going to take the positive integer, and root 2 is going to be negative b minus. It's going to take the negative part of the equation, and the other one is going to take the positive part of the equation, with negative b minus the square root of the discriminant over 2a. That's root 1 and root 2. Then we print f. This f is crucial. We print f. The roots are real and different when we go to the new line. Then print f. Still, the root 1 is going to, the word root 1 is going to come, like root 1 and root 2. Well, root 1 and root 2, they're going, these words root 1 and root 2, they're going to be placed in these place values which are going to have 2 DPs, and after you enter the value of A, B and C, they're going to just be computed, and root 1 is going to be equal to the value of root 1. Like it's going to be equal to a certain value, and root 2 is going to be equal to a certain value according to what you entered. Well, the next part, the next condition, we have the condition for the roots to be real and equal. See, well, this condition is only and only possible if the discriminant, if this discriminant is equal to 0. If the discriminant is equal to 0, then the roots are going to be real and equal. Well, we saw here that the roots can be real and different only if the discriminant is greater than 0. Here, if the discriminant is equal to 0, root 1 is going to be equal to root 2, which is equal to negative b over 2a. Since according to the bulldozer, if this discriminant is equal to 0, meaning it's not worth writing there, so we're going to be having negative b over 2a. Just then we print f, the roots are real and equal. Then on the new line we print f, the root is equal to root 1 is equal to root 2, which is equal to 1 place value, which is equal to 1 root. So this part you can have root 1 is equal to root 2, which is equal to this place value of 2 DPs, and either root 1 or root 2 doesn't matter because it's the same. And the next part, we have if the roots are not real. If roots are not real, meaning they are complex. Well, see, in the bulldozer equation, this part, the first part, the negative b over 2a, the negative b over 2a is the real part, and we have the imaginary part, which is the discriminant over still 2a, because 2a is all over the equation. And so since the real part and the imaginary part are separated by the addition and subtraction operands, so operations, so they're going to share this 2a. Well, the real part is equal to negative b over 2a, and the imaginary part is equal to the negative discriminant, by the way, the negative discriminant over 2a. When we print f, the roots are complex and different. When we go to the new line, we print f, root 1 is equal to this place value plus this place value I. This I indicates the complex part. So we're going to have the imaginary part of the root, the real part of the root, and the imaginary part of the root. That's root 1. And root 2 is going to have this minus this I. Well, this is its real part and this is its imaginary part. The I indicates the complex. Well, as you see here, this real part is going to come here, the real value is going to come here, and the imaginary value is going to come here. Still, this real part is going to come here, and the imaginary part is going to come here. Well, that's the equation. We return 0 to show that the program is done. That's it. So if you try to run it, it's going to show that enter coefficient A not equal to 0, so you enter 7, coefficients B and C, you enter 9 and 7. So this is my example, just my example. Then the roots are complex and different. So if you enter, so if they are trying to run, if these are your inputs and you run, this part where the root is going to be real and different, it's going to be complex and different. These are the answers. Just this is root 1, this is root 2. Okay, thank you. That's it.